The long product life cycle has always been a big part of the LED lighting value proposition. In order for this proposition to hold, the quality of the LED drivers is one of the critical factors that we must also consider. Given the very different quality of LED drivers available in market, very often when we find a LED lamp that no longer works properly, it's actually the case that the particular LED driver fails to operate. If we replace the LED driver, the LED lamp would operate as new again. As most LED drivers are constant current drivers, the best performance can only be achieved by having the replacement driver with the same set of output rating. However, in reality, sometimes it's not that straightforward to find an LED driver that has the same combination of output voltage and output current for replacement. Here is a LED downlight that no longer functions. The LED driver is attached at the back of the heatsink and has the marking of output DC 27 volt to 42 volt, 310 milliamp plus or minus 5%. And here we have a selectable output constant current LED driver from our business partner IDB Power Technology. This particular driver has an output voltage from 5 volt to 60 volt and an output current range from 150 milliamp to 900 milliamp. To set the output current, the driver has a 4-bit dip switch, this one, the red one, to set the output current in step of 50 milliamp according to this table. So the current setting is 300 milliamp. So what we're going to do is to replace the old LED driver with this new driver and add a dimmer to the light and make it a dimmable LED lamp. Now to do the demonstration, we have this connect, okay, the original LED driver, okay, and this is the new connection to the new driver. Since the replacement driver supports 1 to 10 volt dimming control, we have also connected the driver with our new device, with our DIMEZE 1G110, our 1 to 10 volt controller, to implement the dimming functionality to the same lamp. Note there are 3 sets of connections for the driver. This is to the AC power, and this is for our 1 to 10 volt controller, and this is the output to the LED panel. So now we have already set 300 milliamp for the LED driver and connected to the lamp. And note for the 1 to 10 volt connection, the most often mistake people make is to connect the plus or minus terminals wrongly with the LED drivers. So do note the DIM plus and the DIM minus must be connected correctly to the driver. If connected in reverse, the lamp will still light up, but there's no dimming functions coming from the driver. Now, as soon as we connect to the power, you can see the new setup now has the dimming function added. Okay. Now for the argument's sake, let's also set the driver with 350 milliamp as output current and connect it. Now with the 350 milliamp set, okay, you can see it's a little bit brighter in this case. The 1 to 10 volt controller provides the brightness control in scale from approximately 10% to 100% or equivalent to full brightness. The minimum trim option available with our DZ1G110 helps further adjustment of the lowest brightness level. To set it, we first dim the light to the current lowest level, and then we can use a screwdriver to manipulate the level like this. Okay. For our device, the minimum trim option can set the minimum level from 0.8 volt to 3.5 volt. In other words, once set, the dimming range would be from the minimum to 10 volt. For example, if we set the level to be 3 volt, we may dim the lamp to approximately 1/3 of the maximum brightness level to 4. There's a little trick here that if we still find the brightness level too bright, we can further lower the output current from the LED driver, say to 250 milliamp in this case. In this case, we have just set the brightness level, the output current to 250 milliamp with this LED driver. Of course, once we do this, the full brightness would not be as bright as before. Okay. However, this is a common practice for replacement projects that basically do not accept any changes to whatever has been installed. Note that some 1 to 10 volt dimmable LED drivers will switch off the lamp if the control level drops below a threshold. So the final performance may also subject to the combination of the dimming control unit and the LED driver design as well. So for those who have this particular kind of requirement for your application, please check with your LED driver manufacturer if such function is available. In conclusion, in this short video we have shown the value of multi-output constant current LED drivers, sometimes also called multi-power LED drivers, for replacement, and the flexibility for field installation. We have also shown how easy it is to implement the dimming function to an originally non-dimmable LED lamp. Indirectly, it also highlights the importance of LED drivers for dimming applications. As most LED lighting today require a driver to operate, the LED dimming implementation, the rule number 1 is to have a dimmable LED driver, where it is hidden inside the fixture like a retrofit light bulb, like this, or this with this dimmable GX53 lighting fixture, or with an external LED driver as shown. Okay. As we point out in previous video, dip dimming compatibility refers to how deep both the LED dimmer and the driver can support to give the desired dip dimming performance. With the right devices, implementing the LED dimming functionality is as straightforward as shown. This would conclude our video here. To learn more about our dimming technology and product benefits, please check out other videos in the series. And once again, thank you for watching.